Let's prove that the limit as x approaches 4 of x squared minus 3x plus 8 is equal to 12. For this, we're going to review what the definition of the limit is. We will say the limit as x approaches c of f of x is equal to L if for every epsilon greater than 0, there exists a delta greater than 0 such that when the absolute value of x minus c is less than delta, this will imply that the absolute value of f of x minus L will be less than epsilon. So the crux of this proof says that for every epsilon greater than 0, there exists a delta greater than 0. So this is our job. We need to find delta for our specific function. Okay, so let's work backwards. This is the result that we'll need, so we'll start there. F of x minus the limit being less than epsilon. Well, we can substitute in our function f of x, and our function is x squared minus 3x plus 8. Then we'll subtract off the limit, and we are saying the limit is 12, and we want that to be less than epsilon. Now we'll just begin the algebraic manipulation. So in simplifying inside, we get x squared minus 3x minus 4 will be less than epsilon, and we can factor this into x plus 1 and x minus 4. Now we have the product inside the absolute value, so we can split the absolute values into a product. Absolute value of x plus 1 times absolute value of x minus 4 needs to be less than epsilon. And from here, what we're going to need for our proof is that we want the absolute value of x minus c to be less than delta. Now, c in this case, as we are given, that's what x is approaching, and that is 4. So I can solve this equation, or this inequality over here, by dividing by x, the absolute value of x plus 1 on both sides. So now we have this expression that says the absolute value of x minus 4 is less than epsilon over the absolute value of x plus 1. And this is exactly what we need. So here we have the absolute value of x minus 4 being less than epsilon over the absolute value of x plus 1. This is what we are going to let be delta. Okay, so now that we found delta, we can do the proof. So our proof will start, and we will let epsilon be greater than 0, because for every epsilon greater than 0, if we have the absolute value of x minus 4 is less than delta, but remember we said delta should be epsilon divided by the absolute value of x plus 1. Now we can begin the backwards manipulation of this. So we multiply both sides by the absolute value of x plus 1. So on this side, absolute value of x plus 1 times absolute value x minus 4, that will be less than epsilon. We can recombine the factors into a single absolute value, x plus 1, x minus 4. This will be less than epsilon. And then we can factor it out. So this is x squared minus 3x minus 4 is less than epsilon. And now we're going to rewrite this. So x squared minus 3x, we can write minus 4 as plus 8 minus 12. That will be less than epsilon. This is our function value. This is the limit. And therefore, we can say then that the limit, and we have proved that the limit as x approaches 4 of our f of x is equal to 12.